In the last video, you learned how to calculate concentration from going from a solid, adding it to a liquid, figuring out what the concentration is. So if I said 90 grams of sodium chloride is dissolved in a liter of water, what is the concentration of that resulting solution? That's where we use the moles per liter equation. What we're going to learn in this video is how to do dilution problems, calculating the concentrations after we dilute something. So a lot of times, instead of taking a solid and dissolving it in a liquid, we already have a solution and it's a high concentration. We just want to make it a lower concentration. So to do that, we can just add more water to it. But we can calculate how much or what the new concentration will be. So if you know the final volume, the original concentration, you can calculate the final concentration using this equation. So when you dilute, so let's say I take a, hold on, I gotta get my pen ready here. There we go. So if you take a solution, hold on, my pen isn't working. There we go, I'm back. I got my pen working now. So if you take a solution, it has a certain concentration, a certain volume. So let's say it's like 1 molar and it's 100 milliliters. If you add water to that, the amount of moles in that solution doesn't change. So as you have water, you're just increasing the volume without changing the moles. So we remember we have this equation, moles per liter. As you dilute, you should know that the mole stays constant while you're just increasing the liters. And if you increase the liters, that's going to decrease the concentration, right? If you increase the volume on the bottom. So that's really what this equation gets at. If I increase the volume to 200 milliliters, my new solution is going to be 0.5 molar. Because, right, 1 times 100 equals 0.5 times 200. So this is an useful equation when calculating dilutions. Note that the volume does not have to be in liters. In this equation here, it did. This volume had to be in liters. In this equation, you can have milliliters as long as you have milliliters on both sides. You can have liters as long as you have liters on both sides. The volume units have to be consistent. They can be whatever you want them to be as long as they are consistent. So here is an example. If you take like a concentrated solution, let's say I want to make that more dilute. So you take a milliliter out, put it into here, and then you fill up, add 9 milliliters of water. So a milliliter of the original solution plus 9 milliliters of water. You dilute it by a factor of 10. And then if you repeat that, you see that it's getting lighter because it's getting more dilute. It's a 1 to 10 dilution, then another 1 to 10, another 1 to 10, 1 to 10. So that's why it's saying 1 to 10. Now it's a 1 to 100 from the original. Now it's a 1 to 1,000 and then a 1 to 10,000. So this solution is 10,000 times less concentrated than the original if you do a dilution sequence like this. So when reading a question here, let's do some problems. How do you tell if it's the last type of problem we did in the previous video or a dilution problem? Well, the equation for dilution is this. So is it giving you like grams per liter, how many grams are in a liter, or how many moles are in a liter? Or is it saying that, in this case, you see it goes from one concentration to a second one. So if it gives you 2 concentrations or 2 volumes, it's probably going to be this equation. So in this case, it's saying how much of a 2 molar solution must be added to make a 1.5 liter solution of a 0.5 molar solution. So it's saying that we want to make a 0.5 molar solution that has a volume of 1.5 liters. That's what the question's saying. We want to make a 1.5 liter solution with this concentration. That's our final result that we want. Now what it's also saying is that we have a 2 molar solution made. So I can use that 2 molar solution to do some dilutions to it. So my initial, here we go, my initial concentration is 2.0 molarity. And what is, how much of that initial volume do I need? So how much of this 2 molar solution do I need to dilute it up to 1.5 to end up with this concentration. So now to solve for this, to get V1 by itself, I divide both sides by 2.0 molar. So that cancels out. So now I simply take 1.5 times 0.5 divided by 2. Let's see, that would be 0.75 divided by 2. I think it's 0.375. Let's double check here. Might as well make sure I make the video right here. There we go. It was 0.375. However, everything here is 2 sig figs, so 0.375. I'm going to round that to 0.38. And you might be like, okay, what are my units on this? What are we doing here? 0.38, what does that mean? So what this means is molarity cancels out. I am left with liters. So my answer is 0.38 liters. Or if you want to convert it, it is 380 milliliters. So what this means here is I have a 2 molar solution. If I take 380 milliliters of this 2 molar solution and then I add water until the volume of the solution goes up to 1.5 liters, the final concentration will be 1.5 molarity. Or sorry, 0.5 molarity. So let's say I have a big graduated cylinder. Let's say that it's a 2-liter graduated cylinder. Let's say this is 1. I know that's not perfect there. So what I would want to do is I would want to fill this, so about 0.38 would be right there, 0.38 liters. This solution right now has 2 molar. I take my 2 molar solution, fill it to this. Then what I would do next is I would add water up until it's to the 1.5 liter mark. Now, when I add that water, the resulting solution in here, because I diluted it, will have a concentration of 0.5 molarity. So I essentially took a 2 molar solution, diluted it to 0.5 molar. So there we go. Let's try this one. How much of a 12.4 molar HCl solution must be added to make a 1.5 liter solution that has a concentration of 0.5 molar? So again, I've got this concentration. I want to dilute it down to that. My final volume. So final volume is this. Final concentration. My initial concentration is that. So you should be able to pick those out and plug them into the equation. So let's take a second to do this now. Okay, how much of this initial 12 molar do I need? Right? I've got to dilute it up to 1.5. So, and everything's 3 sig figs now. So just keep that in mind. So now I would divide 12.4 over to this side. That gets rid of that. The molarity cancels out. So my final units are going to be liters. So I take 0.5 times 1.5 equals divided by 12.4 equals, and my answer is 0.0605 liters. And then again, if probably want to measure this in milliliters, so you go 1, 2, 3, or 60.5. Sorry, that's milliliters. So again, if I have my big graduated cylinder, just to keep this in mind, we've got 1 and 2. I need to fill this up. I need about 60 milliliters of the 12.4 molar solution down there. And then I would top that up with water. So the majority of it's water, so you're diluting it by quite a bit, from 12 molar all the way down to 0.5 molar. So that's diluting by a factor of about 24. And then the final solution, when it's all done, is going to be 0.5 molar. Okay, so the next video is going to be how to actually do this in lab, because we're going to do a lab. So we're going to apply the last 2 equations, the last 2 videos, and then I'm going to give you a little bit more practical information. I kind of did that already with the second video here, this video, showing you with the graduated cylinders here what to do. But I'll give you a little clearer directions on that in the next video. Just for now, know how to use this equation right here.